Okay, so really this is supposed to be F parallel. So F parallel and F normal are just components of FG, right? Right. If the car is just moving, and the only thing really, I mean, there's normal force going up, and normal force is a function of gravity. So these two are there, and then this came up. F parallel comes from the cracking of gravity here. So if we look at cracking these two vectors, right? If we crack those two vectors and look at these two x components, we see in the yellow, since Fn is mg cos theta, and over here in the blue, F parallel is mg sine theta, right? Then those horizontal components, this is mg sine theta cos theta, and this is mg cos theta sine theta. They come out to be exactly the same thing. Yeah.
If you added friction, would you crack friction?
Yeah, you'd have to do that too. Yeah, friction would be pointing up the ramp, probably, because the car would slide down the ramp. So then it would subtract from this. Yeah. Can you explain F parallel? It's like when you crack gravity. This is mg cos theta, and this is mg sine theta. And actually, Jennifer said something interesting. If there was friction, which way would it point? Do we see that friction would point up the hill? Because if you're sitting in your car, you don't want to slide down the hill, you want to stay on the hill. And so if there was friction, we would only use this part of friction. Does everyone see that? And so it would subtract from both of these. And that should make sense, because it's going to reduce the velocity that we need to stay at this point. In fact, if there's enough friction, your velocity needs to be 0. Because you could stop on the hill and not slide down. Do you see what I mean? But if the lower friction is, the faster you're going to have to go on the hill to make sure you stay there. Okay, just a nice little thought experiment. Okay. Yeah. What is that? Oh, yeah. Okay. You mean this one? Okay. So basically, what we're doing. So what color shall I use? I'll use this. So we get this vector and this vector. Whether we use Fn or whether we use F parallel, both of them come from gravity. So gravity, as it interacts with this incline, is pushing us in towards the center, right? I mean, you can see if this road was flat and the car was on it, and you push the road up like that, the car is going to fly that way. So the incline is taking part of gravity and pushing it towards the center of the circle. Since both of these come from gravity, they're the same thing. And what we prove that by showing that they are components, that even though they're components of two different of our subcomponents, they're subcomponents of two components, but then they end up being the same thing. So let me just say, first we said Fn. What is Fn? We cracked gravity, mg cosine theta, right, all that stuff, and we see that Fn is equal to mg cos theta. That makes sense, right? Does it also make sense that F parallel is mg sine theta? Okay. Sharon. Hey, tonight's an R. Cool. It's the end of the period, but whatever. If you get this, then go. So we have an F parallel is mg sine theta from this. This is F parallel. This is F perpendicular, but because of those force diagrams, F perpendicular equal F sub n. That's why we got that. Are you okay with that? Okay. So because that's true, we know what this one is, and we know what that one is. Now, we only need the parts of those vectors that point towards the middle. That's why we crack each of them. So even though these two things come from the cracks of gravity, we need to crack them subsequently because we need only the horizontal part. And when we crack them subsequently, we see that this part is this part. It's the hypotenuse. This part is this hypotenuse. But if this one right here, based on this, that's theta. So then this part is the hypotenuse times sine of theta. Right? You see that? Because the sine of theta is going to be whatever this is, like x, and then this is h. Sine of theta is going to be x over h. So then x is h sine theta. Right? And over here, we see that the angle is there. So here's the hypotenuse. Let's call this, I don't know, whatever. I'm going to call this b or something. And this is h. So cosine of theta is going to be b over h. So b is going to be h cosine theta. And this is h cosine theta. And then ultimately we discover that these two things are identical, which should make sense because they both come from the fact that there's gravity, because that's what's pushing them towards the center. Okay? Questions? Questions? Yeah.
Is there a way to prove that the theta to the horizontal is equivalent to the theta used to crack normal forces? Because I know that the theta used to crack gravity is the equivalent by transversal definition.
Right.
But I'm not sure about the theta used to crack normal forces.
You're not sure if that one's there? Okay, let's see. So if we look at just sort of the geometry of it, this is parallel to this. So the vertical component of Fn is parallel to gravity, obviously, because they're both vertical. So I would call them parallel lines, and then I would say Fn and the line on Fn is a transversal that cuts both of those lines. And so I would say like same side, when a line when two lines are cut by a transversal, same side angles are congruent. That's probably the logic that I would use. Yeah.
Why is it that you don't add the two?
Because where did they both come from?
Because and then basically why is that? You crack every sine theta? You crack it.
Well, where did Fn come from?
Oh.
See, Fn is a reaction force. Remember, if there's no Fg, like if there's no gravity, does it make sense to you that that car would just sit there?
Yes.
And it would be fine. In fact, if there's no gravity, this car cannot move in a circle. So gravity is the thing that's getting it done. Now what's happened is Fn is a reaction force that is only existent because of gravity. That's why we can say F perpendicular is Fn. Does that make sense? Yeah. So it's kind of like a reflection of that perpendicular component of gravity. And because that's why you don't add them, because Fn is a reaction force of F perpendicular. It came from gravity, and that's why they both get you to the same point. If Fn was a completely different force of in itself, then we would have to consider it. So if you had, for example, this car and then, I don't know, something ridiculous, like here's the track, this giant track, right? This is a side view, and then there's a big pole in the middle, and it's got a rope, right? So now this car has a jet engine that pushes it, and there's a rope that pulls perpendicularly. So this is some tension, right? Now you have to add whatever the tension gives, because it's a different agency of force. Whereas before, Fn is only there because of gravity. It's simply reflecting the force of gravity, and there you go. You see what I mean? This is two separate things, whereas Fn, even though it's an identifiable force in of itself, it's a reflection of gravity, and therefore. Okay, wow, that was fun. So hopefully that was didactic in some sense. All right, what do we do? Are we working on problems?
Yeah, we're doing the big 5-part now.
All right. Okay, we're gonna try to burn through that 5. Oh,
Oh wow.
crap nuggets. I think.